phone check? Are people here?
Yeah.
Cool. So we have set 3 Q5. Find largest x such that x to the 5x equals y to the y for some y. And even though the question doesn't say, you might want to assume that x is an integer. Well, the answer in AIMO has to be an integer for the final one that you write. So this is kind of assumed that x is an integer. And maybe we should assume y is an integer as well. Okay, so this was actually 2012 AIMO question 5. And statistically, it was like the worst question for everyone for some reason. Like almost no, definitely less than 10% of people got it. Maybe less than 7% or 5% even. I'm not sure. I can't remember. But it was a very devious question again. Have people tried this question?
Yeah.
Yeah. Yeah, so I mean obviously 1 and 0 work. Well, 1 works. We don't really know how 0 works. But so this at least suggests that your answer will make sense. There should be an answer somewhere between 1 and 1,000 for which to put down. Okay. And yeah, I mean if you look at like well, so the fact that no one actually got this the solutions that people actually did come up with were actually really hard. Maybe not the best way to maybe do it. Oh, why does it have to be 5x? I mean, it's just what the question says. But if it wasn't, if it was just x to the x, then you could just pick any, x, and then just pick y to be the same, right?
But it should be 999 if it was.
Oh. Okay, so here is a bit of maybe ingenuity that you could use to try and solve this problem. And I think you might be happy with the answer. Yeah, I think Johnson did something like this and got an answer that was very promising. So, but how would you prove it? Might be another question. So obviously we don't expect people to know Oh, so you're suggesting there's no largest x. Yeah, so the question didn't say that. I think no, the question it doesn't have no meaning just because of something like that. I mean, it certainly has meaning. It's just maybe if you interpret it certain ways, it'll become less meaningful. Okay, so there's certainly an answer if you assume y is an integer. And you might want to consider what happens if y was not an integer. Okay. You know, actually, even the more complicated solutions assume that y is an integer. Okay, and certainly x is an integer, so I guess y, for it to not be an integer, would actually be pretty weird. But in principle, we haven't eliminated it. Okay, so here's something that you might try. You could write, yeah, so I mean, powers, you could usually deal with logs and stuff somehow, but we never talked about logs. So this is maybe a case study in sort of, what would you call it? Sort of ingenuity, ideas that might not be so rigorous, but can be made rigorous maybe later. So you could assume, for example, y is a multiple of x, or you could assume, for example, y is a power of x, and see what happens. Okay, so what happens if you assume y is a power of x? Yeah. Well, x to the 5x will equal x to the L to the power of x to the L, right? Well, x to the 5x equals x to the power of L times x to the L. It's almost like lol, but it's an x and the L's up. Okay, so we know that if x is like a proper base and the powers are equal, then the whole power is equal, then the exponents are equal, right? So we would have 5x equals L x to the L. Yes? Okay, so if you have that, you might conclude that 5 equals L. So you think so y should be bigger than x, right? So L should be bigger than 1. You could do x 5L x to the L minus 1. Yeah. And you get L equals, let's say, well, the 5 is prime, right? So L, if L is not 1, then x has to be just 1. Because if x was not 1, then L being, sorry, more than 2 will give you multiple powers of one number. So L, what if L was 2 and x is 5? Well, then there's an extra 2 at the front, right? So you might want to say that L is 5 and x is 1. So Johnson would definitely object to this, and I wonder if anyone else could object to what's going on. So we'd be stuck here, right? Because that would leave L equals 5, X equals 1, and that would make Y equals 1, and have the maximum be 1. Um, so maybe can we get a microphone check? And so actually, if people are about to leave, this step, all you really need is this next step, and then you can kind of leave and finish things off yourself. But can you kind of tell me what's wrong here? Something seems to be, well, it's not completely wrong. So basically, we're trying to solve, so people who just joined, we're trying to solve, we're trying to find the maximum value of x for which this is a solution to this equation for x and y integers. And we've assumed that y and x, so y is a power of x, okay? After assuming y is a power of x, we get that x and y equals 1. And the question is, what's wrong with what we did? Or maybe there's nothing wrong with what we did. Maybe this whole process just doesn't work. So looking for some comments on what happened here. Okay. Okay, so a pretty cool spark of ingenuity here. And this comes with checking things as well. And I don't think you'll find this even in the answers. No, what? Someone say something? So basically, you might think, well, why would we assume that y is a power of x, right? I mean, so you can't assume. So for example, like if you want to say y is a multiple of x, I mean, y might not be a multiple of x and still have a power that's the power of x, right? You kind of because you could have like powers of primes inside there, and similarly, y might not be um a power of x because it might not fit completely inside y, right? So I guess the moment of realization is that this conclusion comes from assuming y is an integer power of x. Yeah. But that might not be true, okay? And if it were true, then x equals 1 would be your biggest solution. So I think you can actually relax it. And this is kind of like a nice little technique in maths to relax it to a rational power of x. Okay, so then this is not a conclusive outcome. Because you can no longer just equate prime factorizations, they're no longer integers. Okay. Right, so yeah, I guess if people really need to leave, so this point is enough to sort of continue on to the problem. You can try and do it yourself. If you haven't registered yet for the AIMO, please let me know the contact details of your parents. And this will be the last term we're with Epping, okay? So from next term on, we'll be completely our own Dr. Sun's School of Maths. Okay, so anyone really needing to leave? If you need to register, you can DM Yi your parent contact name and okay, but you're definitely welcome to stay, yeah? So from now on, for the rest of this term, I don't mind if you kind of hop between classes because I think we're gonna have to make the most of all our resources to really prepare for this. There's a lot to do. Um, yeah, so Ronnie, I'll sort you out in like half an hour or something. Okay, so um okay, so I'm gonna just continue with this now. So this is actually a pretty remarkable remarkable step, okay, because you reduce the number of variables in a pretty strong way by just sort of imposing a very loose condition. And actually, so it's totally this totally up to you right now whether you dwell. So like someone like me might dwell on whether you can actually assume that y is a rational power of x or not, whereas a young person might not dwell on that as much and see what value of x you can get, right? So there's two things to investigate. So okay, so the two questions is can we prove y is a rational power of x? And the other question is what solutions do we get? What solutions do we get if we assume y is a rational power of x? Okay. Where is it? Okay, so I think it's more natural to go for the second path because I mean if you got a solution, you would have a chance of it being right, especially in the AIMO, even if you couldn't prove it. And you could get something right away, right? Whereas if you're trying to prove it, you might never get anywhere, and it might not even be true. Okay. But it might be the case that the other solutions are not in some other satisfying some other criteria. Okay, so maybe the more proactive students would have already just subbed in rational values of L to try and make this work. So what do we get? So 5 equals L times x to the L minus 1, right? So then, how do we do this? We have 5 over L equals x to the L minus 1. Or you could take the L minus first root of that equals x. Okay, so what does rational mean? L is a fraction, right? Where a and b are integers. A over b are whole numbers. So this becomes. Can we get a bit of a microphone check just to see people are still. My audio is still working.
Yeah.
Okay, cool.
Yeah.
So if L is equal to a over b, okay, then it's 5 times b over a, yeah? To the power of 1 on a over b. And I think we can assume a is bigger than b, right? But it's equal to x. So another way of writing this, 5b over a times b over a minus b. Can people see what to do from here? Well, for this to be an integer, and we know that we can assume a and b have no common factors, so we write it as a simplest fraction. Then a needs to divide 5, right? So L has to be 5 times something. So if a divides 5, then a equals 5, right? Well, it could equal 1, but then we know that L is not smaller than 1, right? So this means that L equals 5 over b. And this is equal to b to the power of b on 5 minus b. Microphone check. A suggestion on how to continue. So we want the integer to a rational power to be a integer, right? So we want like 3 to the power of like 7/2 to be a integer. That's not going to work. That's not going to work for all numbers, right? Yeah, so basically, as Yi said, we basically need this to be an integer, or we need b to be some kind of 5 minus bth power, or some combination of actually maybe not, can't have a combination of the, so if it's not an integer, yeah, so if you look at this fraction, right, this fraction b over 5 minus b, like if you look at a common factor, if some common factor divides b and it divides 5 minus b, yeah, then it should also divide the sum, which is 5, yeah. So the only common factors that you can cancel from that, the top and bottom, are 5 or 1, but a is already 5 and b has no common factors with a, so it can only, these two things are, it's the simplest, it's already simplest. So if the fraction is simplest, right, the only way to make it an integer is to make the denominator 1. Yeah. So if the denominator was already 1, then you wouldn't be able to, they wouldn't need to cancel anything. So if it was an integer, then you would get b equals 4, right? So if you get b equals 4, then you get x equals 4 to the power of 4, yeah? So you might want to test this, and you have L equals 5/4. So you have that y equals x to the power of L equals 4 to the 4 to the 5/4. And this is just 4 to the 5. Yeah. So we have that x to the x, 5x. So 4 to the 4 to the power of 5 times 4 to the 4 is that so it's supposed to equal 4 to the 5 to the power of 4 to the 5. Okay. Is that true? We'll simplify some powers. Hopefully people can do this by themselves. The power to a power, you just times the powers. That's 5 times 4 to the 5. And here it's 4 times 4 to the power of 4 times 5 times 4 to the 4. So then you can see the 4 collects to get to a 4 to the power of 5. And they are actually equal. So here you've reached an interesting point where you have a candidate for your answer. 4 to the 4 is 256, right? So, I mean, the answers in AIMO questions 1 to 8 has to be between 0 and 999, right? So, and 256 is getting quite far up there. So, you might wonder if it's the maximum or not. But even if you didn't know, you might actually feel quite happy with putting down 256 because it's actually quite hard for anyone to come up with it. So even just putting down 256 and not knowing why, okay, was not really. I mean, the total number of people who got this question correct, I think it was less than 7% or something. It was like a statistical anomaly because it was only a question 5, but it was kind of strange enough to stump people, or at least it might make them think that they should know something that they don't. That's usually a killer. It was so. Yeah, so Johnson, if you wrote this, I think you would have got it right. At least full marks, yeah, even if the proof wasn't there. So now the question is, were all the assumptions valid? So I guess if you look at the arguments, there was one little choice here with this power, and there was whether or not we can actually assume y as a power of x. Yeah. People have any ideas? So maybe I can take care of this one for you. So can you see it's actually not too difficult if you assume that x to the 5x equals y to the y, right? Then actually y equals x to the power of 5x on y, yeah? And this is a rational number. So indeed, y is a rational power of x. It's a little bit tricky because the power is not constant, it actually depends on y, right? But once you fix y, the power of x is also fixed. So I don't remember actually investigating this part. But can you see you're kind of very sure that it might be 4 to the 4 even though you haven't proved it? And in this test, proving it wouldn't give you any more marks if you view it like that. But in like the grand scheme of things, it may amount to marks here and there. Okay, what if b was a 5 minus bth power? What does that even mean? If b equals, let's just for simplicity say like 3 to the power of 5 minus b. What does that even mean? It was this b times 3 to the b equals 3 to the 5. Oh, okay. So you're saying put it in positive indices. 3 to the b times b equals 3 to the 5. Huh. So that makes b equal to 3 to the... It's a contradiction, maybe? Yeah, so if b was like... So b has to be a power of 3 by unique factorization. Did we at some point say b had to be less than 5? I guess so, yeah. Oh, if we said b has to be less than 5, I guess we could just try all the numbers less than 5, but yeah. So this is another contradiction here. So if b was equal to... So can't equal 5, it can't equal 1. So it could equal like 2 or 3. We already dealt with b equals 4. So b equals 3 gives you 3 to the power of 3 over 2. Yeah. B equals 2 gives you 2 to the power of 2 over 3. Yeah, and they're certainly not like, cubes or squares that would make this an integer. Oh, we said b is less than 5 because L is bigger than 1, because y is bigger than x. Wait, did you get that?
Show you why.
Okay, sorry about that. So, are there any questions about this? So if you want to actually look at another way of solving it, you can maybe consider prime factorizations and how primes divide each sides. Basically what Yi was doing like a week or so ago. I think that's what the official solutions say. But it's kind of crazy you can get to the answer without actually solving it properly. But the way of actually solving it, getting the answer actually leads to a proper solve as well. Alright, can we get a microphone check? Any questions? Alright, I'll let Yi take over.